So properties of exponents. You've been working with exponents, right? And multiplying and dividing them and whatnot. Just real quick, what is it? Somebody tell me what it means to multiply something, two things. Any ideas what that means? I don't know what the common answer is, right? But
it's to add it by itself multiple times.
yeah, it's like repeated addition, right? Okay. Or exponents would be repeated multiplication, wouldn't it be? But could you also think of it like a change of units? Maybe? Like let's say you find an area of a rectangle. You know, and it's five inches wide by 6 inches long, and you multiply that, and what's the result?
Mm-hmm.
5 by 6. What's the area of that rectangle? 5 inches by 6 inches.
That would be 25 by.
No.
30 inches?
30 what exactly?
Was it inches? Wasn't it?
It's area. And we did.
Oh, inches squared?
Right, because you did 5 inches times 6 inches, right? Inches times inches is what?
Inches squared?
Inches squared. So couldn't you also think of multiplication not just as repeated addition, but a change of units? Right? Okay. Let me, so you have that in your brain. Before we get started, I want to give you a quick note. This should be review. So again, we're going to go to that blank notes page, a couple pages in, over on page 12. So you're going to want to go over there and jot this down. Okay. Let's do a review of exponent properties. Okay. So for example, if I have x squared, what does that really mean? Isn't it just x times x? Yeah. Right? And what does x to the fourth mean?
X by x by x by x.
Right, etc. So you get the idea there. But what if I multiplied those two things? What would it mean to write x squared times x to the fourth? Well, the x squared is x times x, right? Times x times x times x times x, right? So here's our x squared and our x to the fourth. And what's the result of that?
X by 6.
X to the 6th power.
By
right?
6.
Okay. So when we break it out that way, what did we actually do with these exponents to get the final result?
You just added them.
Added them, right? Okay. So if I multiply two terms, you know, that are the same, two x terms, I just add the exponents. So we have like a little rule we just generated here, right? So if I have x to the m power, whatever m is, times x to some number n power, what would that actually equal? X to the what? You just said it.
X to the mn.
I thought you said to add them.
Oh, m plus n.
M plus n, right? So there's an exponent rule, right? The power times a power, okay? And, you know, the example I gave you should explain exactly why that is, all right? But what if I have, say, x to the third, right, squared? To square something means to multiply it by itself, right? So wouldn't that just be x to the third times x to the third? And let's apply that rule we just generated. And what's the result of that? X to the what?
X to the 9.
No.
Oh, x to the 6.
Yeah, we're multiplying here, so we add those exponents, right? So if we're doing a power to a power, what do we actually do with the exponents?
Multiply.
You multiply the exponents. Multiply exponents. And maybe I should write up here, we got to write that, we add the exponents. Okay? So power to a power, we multiply the exponents. So we've got another rule here, don't we? Let's say I have x to the m power to the n. What would be the result of that? X to the what?
Mn.
Mn. M times n. Okay? So there's another exponent rule we just generated. All right, so a power to a power, we're going to multiply the exponents. All right? Well, what about division? Let's think about that for a minute. Let's say I have x to the 5th over x squared. Well, x to the 5th, right, you know, is this, over what? Okay, good thought, kids. Okay, now, if I have this situation, do some things cancel here?
Yeah.
So a pair of those x's cancel, another pair cancels, right? And what am I left with? X to the what?
X to the third.
X to the 3rd. So what did I effectively then do with these exponents when I divided?
You subtracted the exponents.
Subtract them. Subtract exponents. Okay? So now we have another rule, don't we? So if I have x to the m divided by x to the n, that would be what? X to the what?
N minus n.
There you go, m minus n. And you might end up with some negative exponents when you do that, and that's fine. We'll address that later. You guys can't remember what they do now in algebra. Do you do negative exponents in algebra 1? Like if you had x to the negative 2. Let me just write down another example. Let me flip this thing I have at x to the 5th. What if I do x squared over x to the 5th? Right? Wouldn't that be x to the 2 minus 5, right? And what does that equal? X to the negative 3, right? Wouldn't that just be this? Right? Because the 2 that were on top canceled with the 2 on the bottom. There were 5 on the bottom, right? And then just 1 over x to the 3rd. Now it's a positive 3 when I put it down there. So have you seen negative exponents? That's what I'm trying to get at.
Yeah.
Okay, so I don't want to proceed, you know, assuming you knew that if you didn't. Okay. Anyway, so there's some properties of exponents. Let's go back now. Everybody have that written down? Let's go back to our first page. Thinking about our properties, let's look at our first example. Find the product. That means multiply, right? So in part A, we got 5x squared times 3x to the 6th, right? Well, let's start out then. What's 5 times 3?
15.
15. And now, since we're multiplying x squared and x to the 6th, what do we do with those exponents? What do we do with the exponents?
And
Add them. So we get x to the what?
8.
8. Okay, simple as that. Let's go to example B. Let's start out with the constants there. What's negative 2 times negative 6?
12.
What? Positive 12, right? Now this x here, it's actually x to the what? First, right? And so we're going to have, when we add those exponents, x to the what, everybody?
X to the 5th.
Okay, good. Let's go to part C. What is 3/2 times 6? Okay, good grief.
Nine on the 9.
Okay,
9.
so for those who aren't sure, when you're multiplying by a fraction, this top part means to multiply and the bottom one means divide. And you can do it in any order, right? So what is 6 times 3?
18.
Divided by 2.
9.
9. Let's try it the other way. What's 6 divided by 2?
3.
3 times 3.
9.
9, right? Either way you do it, right? So top number means multiply by it. So we get 9x to the what?
14.
14 when we had those. Okay, now we have a power to a power, right? What are we going to do with those exponents?
Multiply it.
Okay, so first thing we have to do is 4 squared, which is what?
It's
16.
16
yeah, 16.
x to the what? What do we do with those exponents, power to a power?
Multiply.
Multiply, x to the what?
X to the 6.
There we go. Okay. All right, we're getting back in the swing of it. Okay, so if you think you kind of understand what you're doing there, everyone go down here. I'm going to give you a moment to try exercise 2, A, B, and C. Okay, multiply those out, apply your properties. Okay, we'll see how we do. Everyone, I'm giving you about 2 minutes to go through that, and we'll come back to it here in a second. Anybody get the first one yet?
Yes.
Go ahead, say it.
20 to the x of the 4 to y is 7.
Yeah. So don't say 2 though when you mean multiply, right? So to be clear, what you just said, right? I'm real picky about mathematical language. What you actually just said was 20 to the x, whatever, right? You said that. You mean times, don't you?
Yeah.
Okay. X to the what?
To the
Fourth
4th.
times y to the
7.
7th. Okay. Everybody good with that one? Okay. Move on to B.
8 to the
8 times
8 times x to the 9 times y to the 9.
All right. Everybody agree with them? Okay. One more. You said 1 1/4?
Yeah, 1/4.
Okay. I'm just going to leave it as an improper fraction. That's fine. And what I'm about to write is equivalent, right? 1
Yeah,
times
1
5 is 5.
25.
2 times 2 is 4, right? So 5/4 x to the 3rd, y to the 6th. And you just leave it like that. Generally, we don't have a need to make that a mixed number unless, you know, like maybe you had a plot in the coordinate plane. And how do you count 5/4? Well, you can count 1 1/4, right? Okay. All right. Recording. All right. So let's move on down here. And we're going to kind of do the opposite now, right? So we've been multiplying. And the opposite of multiplying is dividing, right? Okay. Another kind of fancy word for dividing in particular situations would be what? Whoops. Does that? Would be what?
Factoring.
Factoring, right? Factoring just means dividing out some factor of something, right? Like the number 10, right? You could say 10 is 2 times 5, right? 2 and 5 are each factors. You with me? So let's take this first example here. We're going to be doing the inverse of what we had been doing, okay? So 6x to the 5th, right? And they're starting you out. They want you to factor out a 2x squared, okay? So what would be the other factor? So anyway, what's 6 divided by 2?
3.
3, right? And then x to the 5th divided by x squared would be x to the what?
X to the 3rd.
Right, we're using that division property. Right now we're subtracting them because we're kind of dividing here, aren't we? Okay, so we're doing the opposite of what we were doing. let's go look at part B. 12x to the 8th. And one of the factors they want you to bring out here is 4x cubed, all right? So what is the other factor?
The other factor is 3 times x to the 5th.
3x to the 5th. Everybody agree with that? Okay. And this last one here, 20x squared y to the 4th. They want you to divide out as a factor negative 2xy to the 3rd. So what would that be?
Negative 10 times x times y.
X times x to the 1st, right?
X
Times
to the 4th times y to the 4th.
to the 1st, yeah. And you don't have to say to the, I said that just to make sure, you know, okay, subtracting them, you're going to have a 1 there, right? But we don't have to write that in there, okay? Okay. Let's go to the next page. And now we're going to flip back and kind of do the opposite of this now, right? We're going to use the distributive property of multiplication over addition, okay? So you guys know how to distribute, right? This shouldn't be too hard. We're going to apply our properties of exponents, okay? So when we distribute, we just take the term that's outside and multiply it by both of those things. And in this case, what's the result? What is 2x times 5x?
Next word.
10, yep, x squared plus
Plus 6
6.
x to the 4th.
Yeah, 6x. Can we combine these? Are these like terms?
No,
They are not. Okay. Let's do the next one. So now we got to go 3, and I don't need you to draw these little lines anymore. Okay. I know you did that in algebra. You guys are big kids now. Okay. So let's distribute through that 5x to the 3rd. 5x third times 2x squared is what?
10x to the x to the 5th.
10x to the 5th. Okay, keep going.
That is minus 3 minus 15 x to the 4th
Uh-huh. Go ahead.
plus 6 plus 3x to the 3rd.
X to the 3rd. And there you go. There are no like terms here, so that's as reduced as we can get. Let's do part C. What do we get? Somebody chime in. Anthony seems to be doing all the work for you guys. Somebody else jump in there.
Negative x to the 4th.
You mean negative 7x to the 4th?
Oh, yeah.
Yeah, x to the 4th. Go ahead.
X to the 3rd.
You mean plus, right? Because negative times a negative. Yep, x to the 3rd. Yep.
And then negative 21x to the 2nd.
Negative 21x squared. There you go. Good. Okay. I'm going to give you guys a second then and just finish up these last two. So everybody do that. Okay. Do D and E on your own right now. And I'll come back to you in just a moment. Somebody tell me what they got in D.
I was a little confused on these two.
All right. Well, what's x times x squared?
X to the 3rd.
X to the 3rd y squared, right? Go ahead.
Right.
What's the last term?
Y to the 4th. X
Y
to
to
the
the
4th
4th.
times y to the 4th.
Okay? That's the gist of it, right? There wasn't an x and a y in both of those, right? So there was nothing like for one or the other to add exponents with. That makes sense, okay? All right, let's try that last one.
6 times x to the 4th times y to the 5th plus 3 times x to the third times y to the sixth minus 12 times x to the second times y to the seventh.
Okay, everybody agree with that?
Yeah.
Yep, right on the money. Okay. All right, so down here, we're gonna switch gears and go backwards again. We're gonna do some factoring. And the way they word this is in exercise 3 is to fill in the missing portion so that the equation is an identity. In other words, so that it's true, right? So that equal sign here is true. So in other words, we're just gonna, in this first example, take that expression and factor out a 4x, and what will be left? So what's this divided by 4x? 8x squared divided by 4x leaves us with what?
2x.
2x, go ahead.
Mm, 3 minus 3.
Minus 3, and right, 1 minus 1 is 0, right? So there's no x. Anything to the 0 power, you know, is 1, right?
Mm-hmm.
Okay. Okay. Let's move on to B. So we got 7x to the fourth minus 21x cubed minus 28x squared, and it equals 7x squared times something. What's the something going to be? Just feel free to say it, anybody.
1x squared,
So what is it?
1x squared,
Yep. We don't need to write the 1. So x squared
minus 3x,
minus 3x
minus 4x. Wait, no, what did we do? Minus 4?
minus 4, right? Right, because x, so the x squared divided by x squared, right, equals x to the 0, right? And anything to the 0 is 1, right?
Yeah.
Okay. Let's move on to part C. So we got that big mess, and we're going to factor out a 5xy squared. What will that leave us with? Let's divide that first term by 5xy squared. I'll get you started. 2
times x to the second minus 4
minus 4
times x to the fourth times y to the fourth
first, yeah, so just 4xy, yep.
plus 7 times x to the times y to the third.
Right, the x term cancel, right? 7y to the third, right? Any questions on that one? So guys, at any time at all here, we write something down that you don't get, you stop us and ask a question, all right? That's why you're here. All right, one more to go. We got this. So to be clear, right, are the terms of an expression, terms are, you know, anything grouped together with multiplication or division, right? So this is a term, right? And this is another term. Get the idea? So we're going to factor out an x minus 2 from each of those two terms. Those two, so really it's a binomial. So when we factor out an x minus 2, what are we left with? What's 4x squared times x minus 2 divided by x minus 2?
4x to the third.
No, not to the third.
Oh.
Look, let me take this term here. 4x squared times x minus 2, right? Divided by x minus 2.
5x, no, 4x times 2.
Oop.
4x to the second.
So it still's a 4x squared stays, right? Go ahead.
Yeah, and then minus 9.
Minus 9, that's it, right? Because then if I was to go back and take this and distribute this x minus 2 through there, I'd end up where I started, wouldn't I?
Mhm.
Okay? So, there we go, a little review of exponents. You need to get comfortable with those, okay? Stop this.
So